A DaemonSet is for workloads that should run across nodes, usually one pod per matching node. DaemonSets are common for node-level agents, log collectors, monitoring agents, storage plugins, and networking components. A deployment asks for a number of replicas. A DaemonSet asks for coverage across matching nodes. That difference is the whole point. The DaemonSet controller watches nodes. When a matching node appears, it creates a pod for that node. When a node disappears, that pod goes away too. If the cluster grows from 3 nodes to 4, the DaemonSet should create one more pod for the new matching node. No replica count edit is needed. Like other controllers, a DaemonSet uses selectors and pod labels. The selector is how the controller knows which pods belong to it. The selector is not just decoration. In a DaemonSet, spec selector must match the labels in spec template metadata labels. If they do not match, the API rejects the manifest. After a DaemonSet is created, its selector cannot be mutated. Changing ownership rules later could orphan pods, so choose the selector carefully before applying it. A DaemonSet does not have to run on every node. Node selectors, affinity, and tolerations can limit which nodes are eligible. If the pod template has no node selector and no node affinity, the DaemonSet controller targets all nodes. Add those constraints only when the daemon should run on a subset. If control plane nodes are tainted, a DaemonSet will not run there unless its pod template has a matching toleration. That is often intentional. Kubernetes automatically adds several tolerations to DaemonSet pods, including not ready, unreachable, pressure conditions, and unschedulable. That is why critical node agents can run early or stay during node trouble. The DaemonSet controller creates a pod for each eligible node and gives it node affinity for that target host. Then, the default scheduler typically binds the pod to that node. For important node-level functions, the docs note that a DaemonSet pod can use a higher priority class. That helps critical agents get scheduled when node resources are tight. The manifest looks familiar: kind DaemonSet, a selector, and a pod template. The controller uses that template to create the per-node pods. Real DaemonSets often look like node agents. A log collector might mount host paths such as /var/log, request resources, and run in a system namespace like kubesystem. When inspecting a DaemonSet, desired and current counts tell you whether it has the expected coverage across eligible nodes. If the counts do not line up, describe the DaemonSet and inspect events. Then compare nodes with the pod list to find which eligible node is missing a daemon pod. Use wide pod output to confirm placement. You should see one DaemonSet pod on each matching node. If a DaemonSet targets only matching nodes, label changes matter. When a node starts matching, the controller adds a pod. When a node stops matching, the controller deletes that pod. When you change the DaemonSet pod template, Kubernetes can roll the agent pods across nodes, similar in spirit to a deployment rollout but tied to node coverage. DaemonSets have update strategies. Rolling update is the default and replaces daemon pods in a controlled way. OnDelete waits until you manually delete old pods before replacements appear. For updates, you can set an image, then watch rollout status. A successful DaemonSet rollout means the updated daemon pods have replaced the old ones across the targeted nodes. If a rollout is stuck, common causes are resource pressure on a node or a broken template, such as a bad image. Compare nodes, daemon pods, and events before changing the controller again. Bare pods can be placed on a node, but a DaemonSet replaces pods that are deleted or lost during node maintenance. Static pods are different again. Kubelet watches local files, and they are not managed like normal API objects. Daemon pods are usually node local, so communication patterns vary. They might push logs outward, expose a known host port, use a headless service, or sit behind a normal service when any daemon pod can answer. The final mental model, a deployment, manages replica count. A DaemonSet manages node coverage. Selectors define ownership, node rules define eligibility, and rollout status tells you whether every targeted node is covered.